let's take a look at our very first problem-solving strategy, our first tool in our toolkit, our problem solvers toolkit. All right, so guess and check. So guess and check, we might typically think that this isn't a problem-solving strategy we want to use or we're not allowed to use, but it's actually a really useful strategy. So when you're doing a guess and check, you want to make a guess and check to see if it satisfies the demands of the problem. And if it doesn't, you're going to alter the guess appropriately and check again, which makes sense, right? If we're trying to find a number and we guess at it and it turns out to be too large, well, then our next guess should be a little bit smaller. So you want to make sure that, just like when Paulia said, you devise your plan and then you carry it out and you tweak it as you go. This is a great example of that, because maybe your first guess was too big, so tweak it to make it a little bit smaller. Or maybe your first guess was too small, so tweak it to make it a little bit bigger. So you want to make sure that when you're guessing and checking, you do have some sort of a strategy as to which direction your next guess goes in. Okay? When the guess finally checks, a solution has been found, which makes sense. So now let's take a look at a problem, an example of where we can use guess and check. In this first diagram, the numbers in the big circles are found by adding the numbers in the two smaller adjacent circles. So if we look at these big blue circles, well, how are we getting these numbers, this 8, this 14, and this 18? Well, what we're doing is we're adding the two adjacent smaller pink circles. So 2 plus 6, that's going to give me my 8. 2 plus 12, that's going to give me my 14. 6 plus 12, that's going to give me my 18, okay? It says complete the second diagram so that the same pattern holds, okay? So this is our problem. So to solve our problem, what we want to do is we want to, of course, use Paulia's principles. The first of which is to understand the problem, and we know what we have to do, right? We have to take these pink circles and we have to make the two adjacent pink circles add up to the bigger circle. So these two pink circles are going to have to sum to 16. These two are going to have to sum to 11, and these two are going to have to sum to 15. We understand what we have to do. Now let's devise a plan. Well, we know what our plan is going to be. We're going to use the problem-solving strategy of guess and check. So now we need to carry out that plan. So I want you guys to hit the pause button, and I want you to see if you can figure out what numbers go in those pink circles by using guess and check. And I want you to really actually do it. Don't just keep watching the video. If you're going to ask your students to use this problem-solving strategy, you need to have experience using it yourself. So pause the video and don't press play until you've figured it out, okay? So just guess and check, try some different numbers in there. Okay, so hopefully you've paused the video, you tried the problem, and you figured out the solution. So let's talk about that. So in this problem, you should have gotten your numbers to be 6, 10, and 5, okay? Maybe some of you got really lucky and on your first or second guess, you were able to get those numbers. And hopefully when you were guessing, you adjusted your guesses appropriately based on what you got, whether you needed to adjust up or adjust down. But probably most of you, it took a lot more than 2 guesses and maybe significantly more. So now we need to think about that fourth principle that Paulia talks about, looking back, and ask ourselves, can we expand the problem to find an easier solution? So we're going to look at the examples and see if there's a special relationship between the numbers in the large circles and those in the small circles. Because good problem solvers are always thinking, okay, well, I tried guess and check, I tried this strategy. Is there a better way I could have done this? So let's look for some sort of a special relationship. So let's start with those numbers in the large circles. We have 8, 14, and 18. Well, how did we get 8? We added 2 and 6, right? 2 plus 6. And how did we get 14? We added 2 plus 12. And how did we get 18? Well, we added 6 plus 12. So you'll notice, oops, sorry guys, you'll notice that we're adding each of the numbers in the smaller circles twice, right? We used the 2 to get both 8 and 14. We used the 12 in both our 14 and our 18, and we used our 6 in both our 18 and our 8. And if we look at our expressions over here, we can clearly see that. We used the 2 twice, we used the 6 twice, and we used the 12 twice. So those numbers are, every number in the smaller circle is being used twice, right? So if we add 8 plus 14 plus 18, let's see what we get for that. That is, let's see, 8 plus 14 is 22, plus 18 is 40. And so, of course, if we add these expressions down here, we would get 40 as well, okay? Well, now let's look at the smaller circles. Let's look at 2, 6, and 12. So let's sum those together. 2 plus 6 plus 12. Okay, 2 plus 6 is 8, plus 12 is 20. Interesting, right? We can now notice that the sum of our bigger circles is double the sum of our smaller circles. And another way to say that is the sum of our smaller circles is half that of our larger circles. And any mathematician would say to themselves, well, why is that? And we sort of know why that is, right? We just sort of talked about it because we're adding each of the numbers in the smaller circle twice. Okay, so they're being doubled to get those larger sums when we're adding those larger sums together. But let's be good mathematicians, and we want to make sure that this relationship holds. So let's look at that second example, and let's sum those larger circles. So 16 plus 11 plus 15, all right? So 16 plus 11, that's 27, plus 15, 37, that's 42. So now what we would expect to find is that the sum of our smaller circles is half of that. So we would expect the sum of 6, 10, and 5 to be 21. So let's try it. 6 plus 10 plus 5. 6 plus 10 is 16, plus 5 is 21. So this relationship does indeed hold, okay? So we've now found a relationship that we can use to sort of solve these sorts of problems. So let's take a look at another one. Okay, so now let's apply that strategy that we just figured out, that the sum of the larger circles has to be double that of the smaller circles, to see if we can figure out this new problem that we're given here. So here, the sum of our larger circles is 12 plus 11 plus 9, which is, let's see, 12 plus 11, 22, 23 plus 9 is going to be 32, right? All right, so I've given my smaller circles the names A, B, and C. Now, using what we know from the previous slide, using what we learned, we know that A plus B plus C is going to be half of 32. So half of 32 is 16. So A plus B plus C has to be 16. And we also know that A plus B is going to give us 12. So look at this, you guys. I have A plus B and A plus B. Okay, I know A plus B plus C has to equal 16. Well, I know what A plus B is. A plus B is 12. So I can substitute that 12 in here. So I know that 12 plus C equals 16 because A plus B plus C has to be 16 and A plus B is 12. So that means that C has to be 4. And now that I know what C is, you guys, it's going to be really easy for me to fill in the rest because C plus B has to be 9, which means that B has to be 5, okay? And then I could go in either direction for this last one. I'm going to do my top circle. So I know A plus 5 has to be 12. So what plus 5 gives me 12? Well, 7. And yeah, that works because 7 plus 4 does indeed give me 11. All right, so finding out that relationship really helped. So guess and check is a great strategy to start with, but as you work through it, you might notice when you do that look back, that fourth principle that Palia gave us, that there might even be a better, stronger relationship or way to solve a problem, but it's certainly a valid strategy.